Hello, Year 10s. It's Miss Bishop here again. We are going to be going over river features today. I believe we did some questions about it in the last couple of videos when I went through the paper, the mark schemes. So what I'll do is I'll go back through those videos, and then next lesson we can go through those answers, and I've put up some questions today and we can go through those answers as well. So what I want you to do is just thinking back, because once we've done rivers, I just want to go over some hazards with you as well. So can you just think about what case studies you would use for tectonic hazards? So this will be your earthquake, your volcano, your tropical storm, anything to do with the climate change, anything like that. Have a little think, and just make a note of them, because if you can't remember them, that's fine, but if you do, I want to double check that the ones that you've got are the ones that you've been taught, because if you want to do something else, that's absolutely fine, but you would need to research it yourself. So if for example we did a volcanic eruption in, say, I don't know, Argentina, for example, but you wanted to do a Mexican one, that's fine. But if I'm teaching the Argentina one, you would need to do that yourself, which is absolutely fine, like I said, but would just need you to do some background revision. Okay, so I'm going to move on now. If you need to pause just to have a little think, that's fine. And then if you've got any queries about those, email me, and we can go through them before the next lesson. So we're going to start with waterfalls today. Waterfalls are a tricky one because a lot of you understand how they're formed, i.e. the hard rock on top of the soft rock, and then it gets eroded, but you never talk about the erosion itself. And this is where you're losing marks in exam questions, because it's asking you to describe the processes that form the feature. So you need to talk about the erosional processes. Okay, so let's just quickly go back over the formation of a waterfall, and where the erosion comes into it. Okay, so if you want to, you can draw these diagrams out. You don't need to do all this writing underneath, because I'm going to talk you through it anyway. But if you want to pause it, draw these diagrams out, and then annotate them, that would be absolutely fun. So waterfalls form in the upper course. So this is higher up in the mountains where you've got steep sides, so the waterfall can fall. You will always have, or most of the time, you will have a band of harder rock sitting on top of a softer rock, okay, which you can see here. So you can see the harder rock is the lighter brown and the softer rock is the darker brown. You can see the river flowing over the top here. Okay, now what's going to happen is the water is going to splash down into the plunge pool. Okay, and the erosion that's taking place here is hydraulic action, which is the force of the waves on the rock itself. Okay, so it's like if you were to spray a hose pipe at a wall, that is the kind of effect of hydraulic action. You will also have abrasion as well, which is where the rocks that are on the base and the rocks that are being thrown over the side will scrape this back wall and underneath here as well. And you will also get possibly a small amount of solution, which is the chemicals in the water dissolving some of the rock, especially if this softer rock here is like a limestoney rock, because it will then erode quite quickly due to solution. Now, after a period of time, because the harder rock takes a longer to erode than the softer rock, you will start to get this overhang here. So you've got here the plunge pool being eroded by that water. And then eventually this harder rock will become top heavy and it will fall down. So you can see in this diagram here, this third one, you can see that that overhang has now started to collapse and those rocks will fall into the plunge pool. Okay, and then that process will repeat and the waterfall will migrate back upstream, and what will be left behind is a gorge, which is a very steep-sided valley, but it's not like a river valley. So if any of you have been to Cheddar Gorge and you've driven through that, there used to be a river there once upon a time. But you can drive through, it's in Somerset, you can drive through and there's some really steep-sided kind of cliffs on either side of the road. And that is where the waterfall used to be, and then it has retreated back upstream, and obviously thousands of years later they built a road. So that is the formation of a waterfall. You have your hard rock, your soft rock, you have hydraulic action, abrasion and solution dissolving, eroding the rock. Okay, it's very important that you talk about those features when explaining your answer. So the hydraulic action is the force of the water eroding that rock as it's falling over the edge and into the plunge pool. Talk about the abrasion of the rocks that are being thrown over the side, and also the ones that are in the bottom of the plunge pool as well, scraping. And then the chemicals in the water. This happens more regularly at the sea, where you've got the salts and things in the water, but it can still happen in river water as well. So there you've got the chemicals dissolving the rock, as it flows over. Okay, so when you talk about that, you must make reference to those features. Okay, ignore corrasion. Okay, that's an old word that we don't use anymore. Okay, so don't worry about that. I would have learned that at school back in the 1800s, but you guys don't need to know it. So we're going to move on now. So this is the upper course. So if you want to pause the screen here just to make sure that you have got any notes that you want to make down, or if you want to pause it to make some of the written notes that are up on the screen. So we've moved from the upper course to the middle course of the river, and we are going to do meanders. Now, meanders are just the absolute bane of my life. Some of the stories that I get from you lot about meanders and oxbow lakes, just, they're comedy gold. So we're going to start off with a meander formation, and then we're going to link that to an oxbow lake. So you start off with a fairly straight riverbed. Okay, you can see that in this diagram here. Now, remember I spoke about a weakness in the side of the river. And I know the video that we watched showed that it was animals burrowing, but please, please, please don't dwell on that. Just say a weakness in the side of the river. I don't care about the rabbits that are burrowing to provide a safe place for their babies. Just to say it's a weakness. It could be a tree root, it could be anything. Okay, so there's a weakness in the side of the river that is then creating that water to divert in, which will then erode it quicker. And then what this will cause is that ricochet effect of the water bouncing from side to side to side. So you've got a weakness here perhaps, and then the water will start to go into that, and it will ricochet across, and then this will then erode, and then you have deposition on this side. So you have erosion on the outside of the bend where the Thalweg is. Remember, Thalweg, Thalweg, which is the fastest flow of water, and that is on the outside bend of the meander. So on the inside bend, you will have deposition. So you can see on this diagram here, you've got erosion on the outside of the bend here, and then you can see all those pebbles on the inside of the bend that have been deposited. Now this is going to happen. So you've got your erosion, 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 and then it will be erosion, 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 erosion. Okay, so it's emphasizing that C shape of, they've made it a bit of an S shape rather than a C shape of the meander. Now, eventually, this is going to erode so much that it really emphasizes that S shape, which will then eventually form an oxbow lake. Okay, so you're really going to have real steep erosion on this outside bend, and it's going to be very shallow here and full of material on this inside bend here, where all of the water is not fast enough to carry that material, the pebbles, the sand, the silt, and it will be deposited, so it will be dropped down on the inside bend. Okay, so if you want to draw those diagrams out, please do. And what I will do now is go on to the next slide, which explains what happens with your meander once to form an oxbow lake once it's sort of a fully fledged meander. So oxbow lakes are still kind of middle, meanders and oxbow lakes are the middle course of the river. So you will find these in those kind of U-shaped valleys that are a bit flatter, where it gets a chance to migrate. So we have got here our meander. You can see the arrows are showing the fastest route, the Thalweg. So we've got the yellow bits here are the deposition, and these lines are erosion. So you can see the erosion, 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 and then you've got deposition, deposition, deposition on the inside bend. Okay. Now you can see here from A to B, this bit has eroded. Okay, and you can see that they are slowly moving together. If this keeps eroding, eventually this bit here will erode to here, and then this bend here will erode up here. And then what happens is, if you move to diagram C, okay, these two bits have actually met. Now what water does is it will always take the shortest route. Okay, it's not going to go the longest route, it will always try and find the shortest route. Okay, like a wave, when it goes back out to sea, it's due to gravity, it will go straight out even though it comes in at an angle. So you can see here that the river is now taking this route. Some of it still will go round this old meander, but eventually this deposition here will build up so much that it blocks off this part of the channel, and you end up with a straighter river channel, and then what is left behind is this oxbow lake, which, because it's not getting any water to it, will dry up after a few months or years. If it rains quite a lot, then they might hang around for a while. So say if this was one in the Amazon, for example, where it rains every day, it might get fed and it might last a little bit longer. But eventually these will then dry up. And you can see, if you watch a documentary, or if you go on YouTube, you can see, if they're doing a helicopter flyover of a river, you can see the old scars where these oxbow lakes used to be. But they aren't there anymore. You can see that the grass or the reeds are a different colour, and you can see that kind of kidney shape that would have been left behind. Okay, so you start off with your meander. The erosion means that the neck of the meander, the neck of the oxbow lake that is about to form due to erosion, that river then breaks through. It might be erosion, or it might be a storm that floods over, and then eventually this bit here will eventually stop getting water to it, because the deposition will block off this channel, and you'll be left with an oxbow lake. And finally, we've got levees. I'm going to include floodplains as well into this, because floodplains are on this. I'm just going to make a note here, because otherwise you will say I didn't, and there we go. So floodplains here. Levees are formed. You can have natural or man-made levees. Okay, if you go to the Mississippi, in America, they do have man-made levees, which are made of concrete, and that's to stop that river flooding, like New Orleans and places like that. Sometimes they work, sometimes they don't. So what happens is, you've got a river here, a river. This is a cross-section of a river. You've got just the sides of the river here, you've got your valley. Now, what happens is when the river floods, just imagine that there's like pebbles and sediment in the bottom of this river here. Okay, there is always pebbles, sediment and stuff in a river because they've broken off from the rocks further upstream. Now, what happens is when this river floods, those pebbles and sands are carried over the side of the river with the floodwater. Now, what happens is those larger rocks cannot get carried very far because sometimes this floodwater isn't very fast flowing. So it becomes too heavy for the water to carry, so it deposits them just at the lip of the river, just at the edge of the riverbanks, okay, the first kind of couple of meters. This smaller material, the pebbles, the silt, the sand, these get carried further out into the field, into the floodplain. Okay, so then when the water retreats and it goes back to its normal level, what is left behind is some larger rocks that form a kind of a ridge at the sides of the river. So it acts almost like a lip or a ridge. So it is harder for the water to go over it because the river will have to become that much higher to get over, to break those banks. So this happens over many floods. Now, these levees might take, a couple of centuries to grow because some rivers flood very rarely. And some, like the River Rother where I live, down in the valley, down in Robertsbridge, that floods every year. I mean, that floods multiple times a year. So sometimes these take very long time to grow, sometimes these don't take very long to grow, depending on how often the river floods and how far away from the coast it is, because the nearer the coast the levees form, the smaller they're going to be because those particles are smaller. Now, the sediment that is left behind in the floodplain, okay, will make that soil really fertile. That's why a lot of farmland is on a floodplain, because those nutrients from the silt and sand create excellent soil conditions. So that's why a lot of farms and animals are kept close to rivers. Okay, so these build up over time. So every time the river floods, that sediment, the larger boulders and pebbles are near the edge of the river, and then the finer particles form the floodplain as they move further out. Because they are smaller, they can be carried in that water. Okay, right, what I'm going to do is I'm going to show you a document with some questions about each of those features. Okay, now our email addresses have changed. So mine is now, if you haven't emailed me before, you will need to email n.bishop@thestlearnersacademy.org.uk. If you have emailed me before, you can still use my Hasler. It will reroute it to my new email address. Okay, so please, if you've got any questions, if you still are unsure with Oxbow Lakes, meanders, I can always do an extra little bit in. And so what I'm going to do is just show you the Word document. I'm going to go through it slowly, and then you can pause it on each question. And then what we will do is I will go through the mark scheme slowly, so you can read it, pause it, read it, pause it. So start off with question 1. Explain how rivers' meanders may change over time. So how do they migrate and move? That's due to that erosion and deposition. Question 2. Study the photograph showing the waterfall at high force. Using the photograph, explain the processes involved, the erosional processes involved in the formation of the waterfall. Okay, that is 6 marks. Study the diagram below, which shows some of the features. Okay, I want you to have a go at doing this. So pause it, fill in the missing blanks. And then I've got here, you've got a copy of some meanders, and I want you to try and draw a cross section. So that's the inside of a meander with the erosion and then the deposition. And then I want you to explain the formation of an oxbow lake for me for 4 marks. And the mark scheme is here. I will put this up. So this is question 1. Question 2. Question 3. Question 4. Okay, I will speak to you all next week. Have a lovely week and I will see you soon. Bye.